share my screen and come over here to the problem or to the quiz. I have I have my screen set up here so that the top is our quiz problems and the bottom is our terminal where we will run and type the answers. All of these problems are 2 points each. So problem number 1 here, create our folder, hello world, touch hola mundo, touch salve mundi. And then the key thing here is, what is this weird glob down here going to do for us? Before running the rm command, I will run the echo command just so we can see what this glob expands to. And if I run this like this, you see that actually, because it's in quotation marks, the glob characters don't expand at all. That inside quotation marks, glob characters do nothing. And so this is literally just star L question mark. If I were to remove those quotation marks, then it would match hello, hola, and world. But since there are quotation marks here, it's just the literal string right here that we'll be passing to the rm command. So when I do rm star L question mark like this, then nothing happens. This file right here does not exist, and so rm doesn't do anything. ls pipe wc-l, still get 6 files here. Nothing got removed. Any questions on problem number 1? Yes. Question is, without quotation marks right here, why does this not match salve right here? And the answer is that the star matches any number of characters, 0, 1, or more characters. And so we have an L right here. The L matches this L, the SA being matched by this star. But then we have the question mark right here. The question mark means match exactly 1 character, not 0 characters, not more than 1 character. And since we have 2 characters over here after the L, this VE does not get matched by the question mark. So this right here does not match salve without the quotation marks. Good question. Any other questions? Problem number 2. Let's reset the terminal down here, Control R, run my CD command. And now I will run touch with different types of quotation marks here, touch hola mundo and touch salve mundi like this. Again, the only difference between the single and the double quotes is how they handle the $sign. There is no $sign here, so these 2 things will behave exactly the same. They will just pass a single string over to the touch command over here, creating a single file. This touch command down here with no quotation marks will have this, the terminal will interpret this space as separating out these 2 parameters from each other, passing both of these 2 things as separate things to the touch command. And so if we run ls, we have 4 different files down here, hello world, hola mundo, and then mundi and salve separately. The for loop down here, for I and star, for I, well, again, let's just do an echo star. Star is going to match all of those things right there. For I in star, do echo. There we go. Done. And then I'll run this first without the pipe wc-l, just so we can see what exactly the output of the for loop is here. But first, this star, again, will expand to the 4 different files. And the key thing here is that because the space inside of these files is getting expanded inside of the glob, it is going to be treated as a single item that will be passed to the for loop here. So each one of these files will have its own loop through the for loop, and we will output each one of those files once with echo right there. So that right there is the output of the for loop. If we pass that to wc-l, there are 4 lines, 4 files, so the answer is 4. Yes. Question is, what would happen if we did not have this done here in the command? The answer is that you'll get an error that in Python, the way Python knows that a for loop is over is with the indentation. Python is one of the few languages, the only language off the top of my head I can think of, where indentation is used for determining when a for loop starts and ends. In most other programming languages, you have some sort of special keyword that tells us when the for loop is actually going to end. And in Bash or in the shell, anytime you have for, it must have a corresponding done somewhere. So you do have to have the done for this to be a valid for loop in the terminal. If we did not have, so the actual error message down here that we're getting is this unexpected token pipe. So the actual error is that we have a pipe without a command in front of it. If we had the for loop like this without the done and nothing else after it, then you can see that it's coming down onto a new line down here, waiting for me to type in more commands. And eventually when I type in done, it will end the actual for loop. Good question. Any other questions? Problem number 2. Okay, on to the fun problems. Number 3. Control R CD. There we go. Initialize our Git repository. Create our evil file, echo evil into -a. And let's make dir.test and touch.test / hello world, like this. I don't know if we ever actually explicitly mentioned this in class at any point, but the quotation marks in the terminal, they don't have to be around the entirety of file name. You can put them anywhere inside the file name, and that's okay. If you have 2 strings that are touching each other in the terminal, it's like they're concatenated together. So this right here is the same as if this quotation mark here was on the outside of the file name. Has no difference at all. And then touch.test / .salve.munde, like that. And cd into our hidden test folder. And we'll do I'll run this git add.star here in a second, but before I do that, let's just visualize what that's going to expand to by doing our echo.star and hit enter. And there are 4 hidden files matched by this .star command. Recall that by default, the glob does not match any hidden files. The glob does not expand to a dot in the very first location. But if we put a dot in the first location, then it will only match hidden files, not matching these non-hidden files down here. So echo.star matches these 4 files right here are what is found by this glob. We're going to be running git add.star. So let's walk through exactly what's going to happen with this command here. The .star again will expand to these 4 files. So git add.munde and .salve, that will just add those 2 files right there. These 2 special files over here are actually folders. This dot over here corresponds to the current folder that we're currently in, which is this .test folder. And when we do git add dot, that will add all of the files in the current folder that we're currently in, including the hello and world files down here. So even though these files are not actually inside of this glob expansion explicitly, they will still get added to the Git repository because we're adding the entirety of the folder right here. Additionally, because we have this dot command right here, we're not only adding our current folder right here, we're adding the parent folder as well. And the parent folder contains also this -a file. So this -a file is also something that's going to get added when I do git add.star. I'll run this command like that. So let's run git status just to verify all of that. And so here you can see that the Salve Munde and the Hello World did get added, and the -a up here in the parent folder also got added. So that was line 8 up here, get add dot star. Let's run git commit dash m first commit, and then git checkout dash b foo like that. Now, when I run git add dot like this, we've already added everything in this current folder. I already actually ran the git add dot command previously with that glob. If I run git status again, you see that there's nothing that has been changed about my staging area by this git add dot command. And so when I run git commit dash m second commit, actually nothing's going to change. It didn't create a new commit because there was nothing in the staging area. Line 13 down here, cd home slash quiz. The home special variable always takes you to your home folder and then slash quiz. So this just takes us to, in this case, it's our parent folder, another way of saying cd dot dot, and get checkout master right here. In this case, actually, the master and the foo branch 100% identical, so this command's not going to do anything. Before I run the ls star, our very last command, let's do an echo star command to see what the star will expand to. The glob expands to this dash a, so ls star is really the same as ls dash a. Hit enter, and these are the 5 files that you need to have listed here to get credit for the problem. That the dash a here, because that file is actually in the folder, it's actually a file. And then because the ls command here effectively had a dash a flag passed to it, all of the different hidden files, the .git hidden file created by .git init, the .test over here that we created manually, and these special hidden files that are always present in every folder. A lot of things going on in that problem, but any questions about problem number 3? Yes. Question is, when I do this right here, why does it show the hidden files? The answer is because this glob right here expands to a dash a. I know that because when I ran echo star up here, I got dash a down here. And so this command right here is equivalent to this command right here, because the star is expanding to the dash a, and ls is interpreting this not as a file dash a, it's interpreting this as the flag dash a, which modifies what ls does to display the hidden files. The dash a again standing for all. If we had a dash dash in front of it, then it would actually interpret everything after the dash dash as the name of a file and not a parameter that changes things. Or another way of forcing that behavior is if we add a dot slash in front of this, then that forces ls to interpret this as a path instead of a command line flag. And so if we just have ls star, we get to that behavior. Ls dash dash star gets us the behavior that we're probably expecting. So a good habit whenever you're using the glob is to put the dash dash in front of the glob or put the dot slash in front of the glob so that nobody can create files that will change the behavior of your commands. Does that answer the question? Good question. Any other questions? Problem number 3? Last one, number 4. Reset our terminal, Control R, CD, that one, and git init, make dir test not hidden, touch test slash hello space world. So in this case, the hello file is getting created inside of the test folder, but the world file is getting created in my current working directory. In line 5, touch test slash dot salve space dot munde, and then cd test add dot. So we're going to add everything, all of the contents of the test folder here when I do git add dot. So that will add the hello and the dot salve files right here. To verify that with git status, we can see that we did in fact add this salve and hello files. Because they're in the test folder, my current working directory, but the .munde and world folder files not in my current folder, so they did not get added with the git add dot command, we can see here they are in my parent directory. They are in the dot directory right here. So that was line 7 that we just executed. We're on to line 8 right now. Actually committing this, git commit -m, first commit, git checkout, spelled correctly, git checkout -b, foo. And now we have this git add // I'll do an echo // here first so that we can see what's going to happen. Again, the .. is my parent folder, so the quiz folder, not the test folder. And then the star will expand to whatever files are inside of that folder. Here we have the test and the world files, but notice that we do not have the .munday file. If I do in ls ... we have test and world, add a -a flag up there. There is a .mundi, also the .git. These are not being added though, because the glob does not capture the hidden files. Okay, so line 10, let's run line 10, git add // git status, verify that we added this world file here, but we did not add the .munday file. Line 11, git commit -m, second commit, and then let's leave the foo branch, back to the master branch, git checkout master. And now we are still inside of our test folder here, not inside of the quiz folder here. So when I do my ls-a, I'm only going to get the contents of the test folder, ls-a, and not the previous folder. So these 4 files right here, ... hello, and .salve. Must have all 4 of those to get credits. And in particular, you must not have the .munday file. Any questions? Yes. If we cd ... back into the quiz folder and at this point do the ls-a, then these would be the 5 files that we would get. Any other questions about anything about the quiz or the terminal? Yes. The question is, when I was in the test folder right here and we did ... / glob, what exactly is going on here? The answer is that the ... here refers to our parent folder. So instead of the test folder right here, it refers to the quiz folder. And then the glob here will match all of the files that are in the quiz folder. So in this case, the only file that is in the quiz folder is the test folder right here. If I git checkout foo again, then that would also have this world file down here. The glob can be combined with arbitrary paths, and it just any valid path. In this case, the valid path being printed down here, ... /test, ... /world will get matched by the glob. The glob will expand into any valid path, and but the ... is just the parent folder here, and the glob matches to test and world. In this case, the way the problem was structured, you didn't actually need to understand what the ... / here was doing, because we never left the test folder. But that is what it's doing, that it's the star can be anywhere in the path. And so here, find all of the files in the parent folder. Did that answer your question, Avizer? And then the question is, there are some files in the parent folder. Why is it not getting the files? And the answer is that the glob never matches a dot at the beginning of the file unless you specifically place it there. So we'd have to put a dot right here, and then it would match the hidden files. If we do that, then here's all of the things that it matches, which doesn't overlap at all with these ones up here. Um, good questions. Any other questions? Okay, total up your score and get your quizzes passed up to me. Any other quizzes for me? Okay, today in class, we're gonna have a relatively short class period. We've covered all the material that we need to cover for the last assignments here. So I just have posted a wrap-up folder for us. And we'll go through, well, we'll start with just reminder of the timeline, things to expect for the rest of the semester, and then just some big picture takeaways for the class, and then we'll be done. So timeline, we will have a lab this week, this Friday. You'll be tying up some loose ends with your containers project and getting that posted to something called PyPy, so that which is the repository where that pip install uses. So everybody in the world will be able to install your containers project after your lab. We will not be having any more lectures or quizzes or labs after that, though. That again, I'll be going on the paternity leave. And I will, though, be available for office hours to ask either questions about the homework or if you have the trying to do the extra credit with LeetCode and demoing for me problems. I don't exactly know yet what my availability will be, but I'll post it as I know about that. And then 3 more homework assignments. Again, these two here for everybody. They're already posted, and so you can already have everything you need for completing them. This last assignment down here for only the non-graduating students, it'll be due the very last day of finals week. And it's not posted yet. I'll have that posted for you all soon. Any questions about anything timeline-wise, administrative-wise for the class? Yes. Nor, sorry. That's my, yeah. So the question is about what time for scheduling the office hours. The yeah, again, I don't know exactly my availability, but my default time that I would be making available is the class times here instead of the lectures or the labs to just be available for office hours. Yeah, good question. Thanks. All 3 of these homeworks worth 32 points. Good questions. Any other questions? Anything administrative? Okay, then the big picture ideas for the class. So here for every one of our data structures, you want to know the runtimes of those operations. And we've seen a lot of examples of different data structures with different runtimes. and that just changing the data structure, so like going from a list to a deck or a list to a NumPy array. It's been a while since we've talked about these, but we saw that those can dramatically speed up your program. And there's this idea that there's this no free lunch upper division or graduate level computer science classes would formalize this into a proper theorem. But there is no like one best data structure that will work ideally for all algorithms. And depending on what algorithm you're doing, but depending on what you're doing with your data, you'll have to select an appropriate data structure here. So it's an important thing to keep in mind while you're working, which one of these data structures will be the best for your problem. If you select the wrong one, probably what will happen is you'll get one of these quadratic runtimes instead of a linear runtime. And these are, in practice, like the worst things that can happen, fast enough that you don't notice there's a problem at first. But once you add lots of data, things get really slow, really fast. And this happens a lot in practice, bringing down web pages. I mentioned a couple of these examples before, but one of the favorite ones I know I didn't mention before is about Grand Theft Auto, the video game. The reason I like this example here is if you just follow this link, this is a random person on the internet not affiliated with the game at all who discovered this problem about GTA loading times being too large because they were using an accidentally quadratic algorithm. And this random guy on the internet patched GTA, fixing their loading times from 20 minutes down to under a minute to load a level. And so if you're interested in how a random guy is able to do that without the source code, you can check out that link there. But yeah, lots of examples there. The last sort of part of our course, we've been talking about the difference between binary search and this AVL tree, which is in some sense like a magical data structure. 70 years ago, nobody thought that something like an AVL tree would be possible, where you can get the logarithmic runtimes for all of your operations. And it's really the fact that we can do this that enables all of our modern like computing infrastructure. So things like Google search, how they're able to search the entire internet very quickly. It's because of the balancing properties of the AVL tree. If you do go on to take the big data class, we'll be talking a lot about actually using these trees in practice to make large scale queries fast. So no more implementing them, but actually using them to do cool things. We talked a lot about the different big O notations, big O, omega, and theta. They are not specific to runtimes, but will be used all throughout the upper division CS courses if you go on to take them in different ways. And so this is I guess the AVL tree is like the most important practical thing, but this is probably the thing that will come up in practice or in classes the most often in upper division classes. We also covered a lot of things that are not sort of traditionally taught in a data structures course. So a lot of real world programming things like Git, the idea of test driven development. So having your test cases and writing your code to pass the test cases. This is an extremely popular framework right now for software development. The idea of publishing Python libraries, that's what your lab this week will be doing. All of this open source and MapReduce and bash scripting, very, very powerful tools here. Things that we didn't cover are, we talked about memory management in Python, but there are, as painful as that is, that's much easier than the memory management in other languages like C or C++. The data structures classes at MUD and at Pomona are taught in C, C++, because they're designed specifically for CS majors instead of the data science majors. Python is something called a garbage collected language, so that makes the memory management much easier. Still not easy, but much easier. And so we don't cover those details, and instead we get to cover all this fun stuff up here. Last point here. So using good tools will make you more efficient. So we've used Linux on the Lambda server all throughout this class. And it turns out that even Microsoft uses more Linux than Windows. If you're working at Microsoft, you can check out this article for details if you'd like. And I like this tweet here as well from the Windows developer account. Tell us you're a developer without telling us you're a developer. And the reply down here, I'm using Linux. But even the developers at Microsoft are using Linux for things. Good text editor. So I like Vim. After this course, if you choose not to use Vim, I won't be offended. If you're using VS Code for everything, that's what most people do, probably. Probably about 70% of professional programmers use VS Code. Then like 20% of us use Vim. But whatever tool you use, you should be like familiarize yourself with it, all the shortcuts, the tricks with it. There's this big like culture fit idea in interviews, at software engineering interviews, and basically that's somebody looking over your shoulder, and if they see that you're not using your tools effectively, like they're not going to want to work with you. It'll be frustrating to work with people who don't use your tools effectively. So it doesn't really matter what tool you're using, just make sure that you're using it effectively. In terms of version control, there are things other than Git that people use, but it's like 95% of people use Git. So I would just stick with that. And then as you're writing your own code, focus on test cases first and then write your code. Very common mistake or a common failure mode for students leaving this class working on future projects is to ignore this idea of writing test cases for things, because you think it's easier to not write test cases, to just start writing code, but it's usually easier to actually write the test cases first and write the code after that. In terms of classes, where to go from here. So my recommended course, next course, Big Data, I'll be teaching that in next spring. It's similar to this course in that there's a lot more programming, a lot of practical tips on how to be more efficient at programming. The other two upper division classes we have are data mining and graph algorithms, both of these more math heavy courses. And this one required for the data science major. This one I recommend for everybody for the data science major. But if you're not the data science major, this would be the next course to take. And then last thing, if there is anything else that I can do for you in the future, definitely reach out. So advice on classes, if you have a project that you're working on, want to get involved in research, job search, whatever it is, let me know and I'll do whatever I can to help you all. That's it for our lectures. If anybody has questions about anything, I'll stick around after class, get those answered. Otherwise, I will see you all on Friday.